card object. There are 52 cards in a deck, each of which belong to one of your 4 suites and one of the 13 ranks. The suites are speed, hearts, diamonds, and clubs. The ranks are AC 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, and King, depending on the game that you are playing. An AC may be higher than King or lower than 2. If you want to define a new object to represent a playing card, it is obvious what the attributes should be ranked and suit. It is not as obvious what type the attributes should be. One possibility is to use string containing word like speed for suites and queen for ranks. One problem with these implementations is that it would not be easy to compare cards to see which had a higher rank or suite. An alternative is to use integer to encode the rank and suite. In this context, encode means that we are going to define a mapping between numbers and suite or between numbers and ranks. This kind of encoding is not meant to be a secret. This would be insertion. Inheritance. The language feature most often associated with object-oriented programming is inheritance. Inheritance is the ability to define a new class that is a modified version of an existing class. It is called inheritance because the new class inherits the method of the existing class. Extending this metaphor, the existing class is called the parent and the new class is called the child. As an example, let's say we want a class to represent a hand, that is, the set of cards held by one player. A hand is similar to a deck. Both are made up of a set of cards, and both require operations like adding and removing cards. A hand is also different from a deck. There are operations we want for hands that don't make sense for a deck. For example, in poker, we might compare two hands to see which one wins. In bridge, we might compute a score for a hand in order to make a bid. This relationship between classes similar but different lend itself to inheritance. Class diagrams. So far we have seen stack diagrams which show the state of a program, and object diagrams which show the attributes of an object and their values. These diagrams represent a snapshot in the executions of a program, so they change as the program runs. They are also highly detailed. For some purpose to detail, a class diagram is a more abstract representations of the structure of a program. Instead of showing individual objects, it shows classes and the relationships between them. There are several kinds of relationships between classes. Object in one class might contain reference to object in other class. For example, each rectangle contains a refers to a point, and each deck contains reference to many cards. This kind of relationship is called has a As in a rectangle has a point, one class might inherit from another. This relationship is called is a as in hand is a kind of a desk. One class might depend on another is in the sense that change is one class would require change in the other.